Math 8, welcome. Today we're going to be talking about rational versus irrational numbers. It is one of the parts of your first unit. It deals a little less with knowing the math and just knowing your facts about rational and irrational numbers. So let's get started. First we have rational numbers. Okay, you can see by definition here if you need to pause it to write it down, but a rational number simply can be written as a fraction. Okay, so again, write that down. You have to write a little bit more than usual today. So, some examples of a rational number. Well, if it can be written as a fraction, it simply can be a fraction. Okay, 1/2 is an example of a rational number. Can be written as a fraction. Well, it is a fraction. Okay, similar to 1/2, some of us would know 0.5. Well, that decimal is the same as 1/2, so therefore 0.5 can be written as a fraction. The reason 0.5 can be written as a fraction is because it's actually a terminating decimal. Okay, any terminating decimal can be written as a fraction. It doesn't matter what it is. So whatever fraction it is, you can have something like 4/3. You can have something like 4 2/3. All those are fractions, which means they are rational numbers. Other terminating decimals, 0.25, 0.172, doesn't matter. I mean, you're never really going to run into that decimal, but it's still a terminating decimal. Therefore, it can be a fraction, which means it's a rational number. Okay, other decimals are repeating decimals. Those also can be written as a fraction. So 0.3 repeating. If you remember from the converting unit, 0.3 repeating is 1/3. Therefore, it's a fraction, which means it's a rational number. It doesn't matter what the repeating decimal is. If it's a repeating decimal, it is a rational number. Okay, there's one type of decimal that's not a rational number, which we'll talk about when we do the non-rational numbers. But in your repeating, it could be 0.42, and both of those things are repeating. It's still a rational number. Okay, a couple other things. Obviously, a whole number like -8. Well, -8 is simply -8/1. Therefore, it's a rational number. It can be written as a fraction. It's a rational number. The negative doesn't change anything. It's just a negative number. That's all it is. Okay, the last thing that's a rational number is a perfect square. So what we just talked about, the square root of 36 is a perfect square, therefore it is a rational number. You can know that just by looking at your perfect square list you just made. Okay, it could be a negative square root of 81. Well, that just turns into -9, which is a rational number again. Okay, so all of these are rational numbers. There's a lot more types of rational numbers than there is irrational numbers. Again, if you need to pause the video, copy some of this down, go ahead and pause it now. And we're going to get into the irrational numbers. So, irrational numbers, just the opposite. Can't be written as a fraction, okay? So again, pause if you need to. But examples of irrational numbers, okay? There's not as many. The third type of decimal, okay, so we have terminating, repeating, and then we have ones that don't terminate, which means they never end, and they also don't repeat. So an example of that could be something like 0.29843, and then you'll notice I put a ... after it. That ... represents that this decimal is never going to end, and it's never going to repeat. It's going to go on forever with the random numbers. The famous irrational number is pi. Okay? Pi is something like 3.141529, and so on. It is never going to end. Besides this decimal and pi, the other types of irrational numbers are going to be non-perfect squares, meaning you have a square root and you don't know what the square root of it is. Okay, so like let's say we had, you know that the square root of 16 is 4, so let's say we had the square root of 17. Okay, this is actually part of the next section, but the square root of 17 you don't know. It's really like 4.12973. I'm making up numbers really, and it goes on forever. Okay, so if it's not a perfect square, you don't know it. Okay, therefore it cannot be written as a fraction, and these are your rational numbers. Again, pause the video if you need to. Okay, what you're going to have to do for this unit is state, is it rational or is it irrational, and then why. Most of the time, your reason why is just the definition of it. If you have a fraction, you would say rational is a fraction. If you have a perfect square, you'd say rational is a perfect square. If you had a repeating decimal, you'd say rational is a repeating decimal. Okay? When it's not, when it's irrational, you just simply say what it is again. Okay? Pi, you say irrational because it's pi. Square root of 17, irrational, not a perfect square. Okay? Most of the time, your reason is simply just stating what it already is. Okay? That has to do it for today. This part, again, it's not so much math, it's more just understanding it. Okay, it's a little bit different, but it's not that bad. It's still level 2 stuff. So yeah, hope you're having a good day, and I'll see you next time.